Alright, we have VOX Continental here, and this is an A sharp that's missing on the 16 foot, and therefore we notice that the last divider is not dividing. So we're going to check the pot, and throughout the pot's rotation there is no division. Yet there's no problem, so you can get. Okay, this is an example of the dividers on an A. And here's the A sharp, which doesn't show up. One of the lowest one on the A sharp does not. That's 5, 4, 3, 2, 1, and 0. So the lowest divider on the A sharp card is not running, which is the reason why you get that. It's pretty much a leakage of a tone coming through. Adjusting the pot will make no difference. So we have to assume something has happened to the divider itself. And with an instrument this old, that could be almost anything. Could be a bad capacitor, a bad transistor, even a crack in the board. There's input pulses from the second and last one. And there's that. And that seems to be an input pulse. So it appears that it's not running any other way. Alright, we're going to check the transistors to make sure they're still there. Okay, red is collector, yellow is base, and the black is emitter. So what we're going to do, that's E, and this center section here is B. So that's E, B, C. The way they have that written, so that's E, B, C. So let's go see if we still have a transistor. Now these are germanium. They're going to be a little lower. And they're also PNP. 163, 168, 150, and 150 also. Now it says I've got two transistors that are in there, two diode junctions that operate. Let's see, this would be 2200. It's possible that a capacitor has failed, but it appears it's not being triggered. Normally that should be doing it, coming in through the gate from the other part. The little one 500. Now, look at the schematic. 2200 is 500 picofarads sitting there in the base of each one, looking for a timing pulse. And that 500 comes from the previous stage. And the 2200s, the 2200s are the actual capacitor used as the timing for the flip-flop. So what we're going to do is we want to look on the base of the transistor to see if the unit has anything else coming out of it. So we're going to hook this up to the 9-volt battery again. And after we've had this hooked into the battery, we're going to verify that we have a scope signal. And we do for the other ones except for the last one, as usual. So then what we want to do is we want to go to the base of the transistor, which will be here. And that one has no pulse. And that one does have a pulse. That's normally what would happen is you would see a pulse on either side, a very sharp, steep pulse. And in this particular instance, since I see the pulse on one side and I don't see it on the other side. Okay, what we've done is we've added a small capacitor across one of the cross-coupled capacitors between collector and emitter, and see, that's what we've done is we've gotten an output now out of the 680 picofarads we stuck across there. But it's not dividing properly. Not dividing in two. There's the output and there's the other output, and they appear to be about the same, so it is not totally dividing, yet without the capacitor it doesn't want to go at all. That's the 2200 in there. I can tell this is not going to be my favorite method of hookup. Okay, there we have that one, square. I have a pickup lead here. And now, all of a sudden, okay, so that's not there. Okay. So that's to there. And that isn't going to the right pin. We're going to move the capacitor a little bit. It's on the wrong pin. How special. Nope. Alright, what we've done is change the transistors, and the waveform is now correct. In this particular instance, we had a transistor where there was a loose connection on the emitter, and apparently this resulted in the emitter base junction being biased incorrectly to the point where the transistor failed. Remember, these are germanium. So at this point in time, what we've done is we've replaced both transistors with a higher beta germanium, by the way, and the end result, if you can see on the scope, is that we have our waveform. And now we also have all the others, because here's our main oscillator: divider 1, divider 2, divider 3, and divider 4. So we now have all our dividers in operation. We're going to restore this into the VOX chassis, and you'll find, like I said, for troubleshooting purposes, the method I'm showing with a 9-volt battery, and we're clipping the excess lead off. We don't want anything shorting out. Is often a good policy, because it lets you work on the board and turn it upside down while you're doing it. And now we're going to return this into the chassis. And our lowest A sharp is back.